Hello, scholars. Welcome back. Today, we're going to really engage with science. We're going to explain some phenomenon by building an experiment and actually completing it. To start today, we're going to watch a video that reminds us of the scientific method. Everyone should have gone over this at the beginning of the year, but we're going to watch a vocabulary video to remind us what the 6 parts are. Make sure you have your workbook open and ready because you're going to need to answer some questions in there, and we're going to be using it a lot today to build our experiment. Let's get started.
This is a Galileo, aka a double G, Mamma Mia. Live from the Tower of Pisa, grab a piece of pizza. The 17th century feature is Galileo Galilei, a scientist who questioned everything the church had to say. Like, well, how's about gravity? You think a heavy object will fall rapidly? Naturally, Galileo wanted to use experiments to obtain the truth. So if I drop these cannonballs at the same time, they'll fall at the same time.
Just like we did yesterday, Galileo came up with some questions, and now he's going to do some experiments to test it.
And now he's holding 2 cannonballs, dropped from the top, and both of them should plan to fall. At the same moment, the one was heavier. Boom, proof gravity's constant. Get ready for a revolution. But the church wouldn't listen, and later he was locked up by the Inquisition. That's what can happen when you make a commitment. The scientific method to the madness. What is it? The scientific method starts out when you ask a question. The hypothesis is the second step, then you test it. That's what an experiment is, of course. Analyzing the results is the fourth. Have we reached a conclusion? Do we need more support? That's the 5th step. Yep, we've been waiting. The 6th step, take our results, communicate them.
So we started with a question yesterday. A hypothesis is going to be a prediction or an answer to that question from what we already know. Then we're going to build an experiment to test to see if our hypothesis is correct. Then we're going to take that data that we get from the experiment, analyze it, and see if it affirms or says our hypothesis was correct or says our hypothesis was not correct. And maybe there's another explanation we need to look at. We'll sum that up in a conclusion, and then we'll share that to other people through our 6th and final step to communicate. Let's finish the video.
Shall we dig further? Ask good questions to be a good observer. In this case, it was weight. Does it influence the rate that an object falls? Well, we can improve it. How? By forming a hypothesis, an educated guess for what our thought process is. If gravity is constant, then everything will fall at the same rate accomplished. A controlled experiment was conducted with only one factor that we adjusted. Busted. It was the weight of the cannonball. That was the variable that we can control.
So one thing that we talked about at the beginning of the year is variables. In our experiment, we can only change one thing. If we only change one thing, then we'll know that has the effect or the outcome on what we're looking at. So in this experiment, Galileo only changed the weight of the cannonball. He didn't change from how high he was dropping them. He didn't change what they were made of. He didn't change who dropped them. The only thing he changed was how heavy they were. We're going to make sure that we do that in our experiment. And we're going to talk about some vocabulary around that too once we get started.
The scientific method starts out when you ask a question. The hypothesis is the second step, then you test it. That's what an experiment is, of course. Analyzing the results is the fourth. Have we reached a conclusion? Do we need more support? That's the 5th step. Yep, we've been waiting. The 6th step, take our results, communicate them, take them. The scientific method starts out when you ask a question. The hypothesis is the second step, then you test it. That's what an experiment is, of course. Analyzing the results is the fourth. Have we reached a conclusion? Do we need more support? That's the 5th step. Yep, we've been waiting. The 6th step, take our results, communicate them.
So we just learned the 6 steps of the scientific method. Make sure you fill them out in your copy of your workbook so that you know what 6 steps we're going to go through today. The first step of the scientific method is to come up with a question. We worked on that yesterday. In your workbook for question number 2, please write down your question that you came up with yesterday. I'm going to write my question. Why don't we pause the video and get that done? Now that we have our question written down, we can start thinking about the answer to it. If you did research yesterday, then you may have a good idea of what your answer is. And if you need to come up with a new question, that's great too. So I'm going to write down my hypothesis, or why I think fireflies light up. The next part, our hypothesis, is an answer to our question. Scientists write it in a specific form called the if-then form. We might need to go down to the next section where we talk about the independent and dependent variables. This will help us write our answer in our if-then form. So the next part goes into our experiment. We're just going to touch on what an independent, dependent, and constant are real quick so we can go back up and do our hypothesis. So an independent variable is something that you change in the experiment. A dependent variable is something that you are going to examine or record data on. What is the independent variable changing? So in our question, we're thinking about why fireflies light up. If I'm going to change the temperature of the air, or look at different air temperatures to see how the fireflies light up differently, the independent variable is going to be the air temperature, and the dependent variable is going to be the fireflies. In our if-then hypothesis, we write if the independent variable, then the dependent variable. Here's my example. I'll give you a moment to pause to write your own hypothesis for your own experiment. We have asked our question and we formed a hypothesis or an answer to that question. Now we need to start building up our experiment. We've just talked about the independent and dependent variables. Again, independent is what you control and what you're changing. Dependent is what you're going to measure or look at or collect data on. So in our chart here, fill out what your dependent, independent variables are now. Pause, take a moment to do that. Now that we have the independent and dependent variables of our experiment, we need to think about the things that remain the same or constant so that we can look at just that one thing we're changing. So in my experiment, I need to probably have the same firefly. I also probably need to have the same amount of fireflies. I probably also need to control what's in their environment, whether it's grass or trees or plants or other animals. I need to make sure that I'm going to keep track of how long I'm recording for. Because if I record fireflies lighting up for 1 minute at 50 degrees and 10 minutes and 90 degrees, I'm going to get a whole lot more flashes then. So I'm going to record my fireflies for 1 minute in each of the temperatures. You write down some of yours. Go ahead, pause the video. I hope that you filled out a lot of constants for your experiment. Now, it's time to start thinking about the steps of our experiment. So in this section, I want you to go ahead and plan out what you're going to do. You may need to break it down into a list of steps. So first, I'll collect my fireflies. Then I'll expose them to this temperature. Then I'll expose them to this temperature. So on and so forth. Make sure to include steps about how you're going to collect data as well. Go ahead, start to design your experiment. Like I say in the workbook, it's okay if your experiment's going to take longer than a week. This is a lot of work, and it's okay. If you just want to do this in different chunks, pause the video, leave it for a day, and come back tomorrow, that works great. So while creating my steps for my experiment, remember to be kind to other organisms. They're alive just like me and you. So I'm going to use fireflies in my experiments, but I am going to only keep them just for the experiment and release them right afterwards. I'm going to make sure that I'm not harming them by exposing them to too cold or too high of temperature. I'm also going to make sure that they have air to breathe and things that they need to survive. So if you decide to do an experiment with any sort of organism, whether it's a plant or an animal, make sure that you're treating them with respect and kindness. So for this step, we're going to create a data chart so that we can keep track of how our experiment's doing. So I'm going to show you how you can create a table in your document here so that you can put data in and keep it organized. So if you click Insert in Table, you can draw a different size table. Since my experiment has 4 different temperatures, and I'm recording how many times the firefly flashes, and I'm going to do it 3 different times to make sure my results are the same, I'm going to make a chart that's going to be 5 by 4. That way I have a row for titles on either side, and then I have 3 rows for the 3 times I'm going to do it, and then 4 for the 4 different temperatures. I'm going to finish building my chart. I want you to start working on your chart. Come back and look at mine when it's ready. So here's my completed data chart. I have the 4 different temperatures along the top, and then down the side I have the 3 different times I'm going to do it. In the middle of my chart, I'm going to record how many times the firefly flashes. So for example, the first time I did it, if it flashed 5 times in 60 degrees, 7 times in 80 degrees, 8 times in 80 degrees, and 9 times in 90 degrees, I have some data now. I'm going to do my experiment again to make sure I get something similar. Now that we have all our data, we can go back to our original question and our original answer, the hypothesis, and see if our prediction was correct. Go back, look at your if-then statement, and write a statement now reflecting upon the data. Were you correct or not? Say, yes, I was correct, and why from your data, or no, I was not correct, and why from your data. The last, and I think most important part of the scientific method is communicating and sharing what you've learned. It's best if you share with as many people as you can the insights you've learned. That way, more people can use your knowledge and build future experiments. This way, we can understand the great, fascinating world around us more and more and more as more humans do more science. Communication, I think, is the best part of the scientific method. So, communicate to your family, and you can communicate to me and other science teachers throughout Richmond by posting to our Flipgrid. If anything didn't make sense today in this video, go back and rewatch parts. I've also linked a BrainPop video that explains the scientific method and how to do an experiment. Click the link here and log in with the Richmond password and username. There's also other videos on BrainPop that talk about specific parts of the scientific method in more detail if you have specific questions. Science takes time, so if this takes you more than one day and more than 1 week, that is okay. Keep trying and keep learning about your topic, your interests. If you'd like to test your skills, there's a scientific method quiz on quizzes that I've linked. There's also one on vocabulary and on BrainPop that I've linked below as well. Go ahead and click those links and they'll help you practice your scientific method knowledge. Today, we went through the 6 parts of the scientific method. We started with the question. Then we answered that question with a hypothesis or a guess based on what we already know. Then we did an experiment. We collected that data and used it to make some ideas or conclusions. Finally, we're communicating what we learned to other people. I hope that you made a really cool science experiment, and I'm really interested to see what you guys did. Make sure that you post your experiment that you did in the Flipgrid. Over the past 10 weeks, I hope that you've learned some science. I hope that you have a really, really good summer. And as always, stay safe, stay awesome, and learn something new. Bye.